Hello, students. Um, this is going to be the end of the first week of this 8-week summer course, and I just wanted to pop in and make a video for you guys so that you can finish up the last homework assignment in ALEKS. That's assignment number 6, Library of Functions and Transformations of Graphs, um, over the weekend, so that on Monday we can come back and start reviewing for the test. Okay, so first, let me go ahead and show you guys what you should be looking for in Canvas. So if you're in the modules, scroll down to the bottom of module 1, and you should see a couple of things here towards the end. One, there is actually right here a handout that says graphs of common parent functions. Okay. Now, this is going to be a really useful reference sheet as we get into this next homework because this unit is going to introduce to you a bunch of different parent functions that we should become more or less familiar with as we progress in this material. Okay, there's a lot of different functions right now, and a lot of information is being thrown at you all at the same time, so it can be a little bewildering. Uh, so the first thing you want to know is break this down into its component parts. So this first piece of information here that I'm circling is called a constant function. A constant function represents a perfectly horizontal line. So if ever you see a graph that's just a flat horizontal line, you're dealing with a constant function. That equation looks something like this. F of x is equal to a, where a could just be a number. So for instance, if I clear away some of this stuff that I've drawn, it looks like this line right here is passing through a particular y value, and it looks like y equals 2. Okay, so the equation for this function might look something like f of x equals 2. Okay, so if you see something where the equation is just a plain number and nothing else, there's no variables, just a constant, you're dealing with a constant function. Okay. And so you have a bunch of other functions here, linear functions, which are lines that can go up diagonally, or they could go down diagonally in some cases, depending on the details of that particular problem. But you just need to be able to identify what do these graphs look like. And the parent function for all linear functions is just a basic function that's f of x is equal to x. And sometimes we call this the identity function. Okay. So what you're trying to do here when you review this handout is just match the name roughly to what that type of function looks like, its general shape. Okay, and that's going to be good enough for us. So imagine creating some flashcards where you have the name of the function on one side, and then you have just an image of the function on the other side, just so that you know what its shape looks like. Because if I ask you, what does a cubic function look like? You can use this reference sheet and pull up a cubic function, but you should know that it's kind of this wiggly kind of S-shaped function here. If I ask you for a square root function, you should know that it's this kind of arch-shaped function here. Absolute value function is a V-shaped function. So this handout's going to be really useful for you guys as you get into the homework because there are some matching type questions, and we'll jump into the homework here in a moment and see what to expect. Okay, so review that handout and then watch this video lecture called Introduction to Parent Functions. Okay. There are a couple more handouts here. The next one that's going to be super important is the rules for transforming functions, transforming parent functions, because this assignment is about a library of functions and then also transforming them. Okay, so let's just jump right in and sort of do a few examples here so you know what to expect when you get into the homework. Let's go ahead and take a look at ALEKS. So I pulled up the assignment here, and the first problem is just saying, from memory, match the equation with its graph. And it gives you this equation here, f of x is equal to the square root of x. Okay. Well, right now we're trying to get familiarized with what these functions look like. So if you're not sure what this square root of x function looks like, then go to that reference sheet, that handout that has all of the parent functions, and look for something that's called the square root function. Okay. All you're trying to do is say, okay, well, which of these graphs, A, B, C, D, E, or F, looks like the square root function? Okay. And that's how you'll be able to determine which of these is the correct graph. So you're going to really want to lean on that handout in order to answer these questions. And the first several of these questions are going to ask you to match for memory, but essentially what you're trying to do is build become more familiar or build some familiarity with what these graphs look like. Okay, so that's going to take you through, I think, the first 7 of these homework problems, where you're just going to be matching the equation to its graph. Okay, and then once you get familiar with those, we're really going to want to go back into the modules, because now it says for question number 8, use translations to graph the given function. So what we're going to want to do here is go back to module 1, pull up the rules for transforming parent functions worksheet. Okay. So if we load this up, you can see that there's a lot of rules for transforming functions here. Okay. So first, we want to sort of break this into categories, or have this organized in our head so that we know what we're talking about. And that question that we just saw in Alex said, determine what kind of translation has been applied to the function. So this f of x here can be represented by any kind of function. It can be an absolute value function. It could be a square root function. It could be a quadratic function. Okay. But what this is saying is that all of the functions play by the same rules. If I want to translate the graph, and in mathematics that means shift the graph up or down, that's going to be considered a vertical translation, since vertical means up and down. So maybe I'll just write an up and down symbol here. So if I take a function and I add k to that function, so I'm going to go over here to the absolute value function. Let's say I add some number 3. Okay, so I have the absolute value of x plus 3. Then that's going to shift the graph up k units. Well, if this number is representing k, that means that my absolute value function is going to be shifted up 3 units. If I look at my square root function here and I subtracted 5, I can look at the next rule. If I subtract a constant, then that's going to shift the graph down k units. Well, now this is playing the role of k, and I have my square root function minus 5, so that's going to shift my graph down. Okay. So if that kind of sort of is making sense, then what we should be able to do is go back over to Alex and take a look at what they've given us, right? So we have h of x, that's the name of our function, is the absolute value of x minus 4. And we really just want to focus on this minus 4, okay? Because we should know that the absolute value function, based on our previous reference sheet, should be a V-shaped graph. That's what the absolute value function looks like, okay? But if I subtract a number from my function, then that should move the graph down k units. So in this case, negative 4 or minus 4 means that this graph should shift down 4 units. So it should be moving down to negative 4. The way we're going to do that is we're going to grab this translation tool here and grab our graph, maybe at this bottom point here, and drag that down, just click and drag down 1, 2, 3, 4 units. And then you can click on this translation tool to get rid of it. But that's where the graph should be moved down 4 units based on those transformation rules that we have in that second handout. Okay, so what else do we have to do here? Nothing. We're done. You check your answer, and that is all you have to do here. Okay, so what are we doing in this homework then? It seems easy enough when the instructor does it, when I do it, but is it going to be that easy when you get into it? Maybe it's going to take a few stumbles, but you should be familiarizing yourself with what the equations of these graphs look like, what the actual graphs themselves look like, and be able to put a face to a name, so to speak. You should be able to identify the equation and say, oh, that is a square root function, or that is a absolute value function, okay? And then for questions 8 through 13 here, you're just going to be looking at that second worksheet, or that second handout, transformation rules, and saying to yourself, okay, the equation says what? Well, let's take a look at this example and see if we can do it together. H of x is x to the third power. Which function is that if we look at all of our parent functions? Well, that's our cubic function. And our cubic function, x to the third power, kind of looks like this squiggly shape here. Okay? So that's all well and good. But then what do I do if I observe that we have -5 sort of attached to the parent function? How is that -5 going to change this graph? And what do we need to do? Well, based on the transformation rules handout, if I have a function, in this case it happens to be the cubic function, and then I -5 from it, I have an expectation that that graph should move down 5 units. Okay, so what does that mean? What do I need to do here? It means I need to go ahead and grab my entire function, probably right at the origin, right? That's what you want to do. Click on the origin and then just drag that point and drag the whole graph down 5 units. 1, 2, 3, 4, 5. Okay. You check your answer, and that's it. Okay. So, kind of a brief explanation here of what the resources are that you should be using to get through this homework assignment, but it's just that simple. Try your best not to overcomplicate this, and you should be okay.